Alright, in this section we're going to look at how to do trigonometry with angles that aren't necessarily on the unit circle. So the only difference we have to make is that our hypotenuse is not going to be 1 anymore. It's going to be the radius of whatever circle we have. So all the places where we had 1 or even an implied 1 are now going to be replaced by an r for the radius. So what we've got is the sine is now not just y, but y over the radius. Okay, the cosine is x divided by the radius. Tangent is still y over x. Cotangent will still be x over y. But cosecant and secant are now going to be have an r on the top. So I'll show you how this works. So here I've got a segment that's creating an angle with the x-axis. But now my radius is not 1, so I'm not on a unit circle. I'm on a circle that has a radius of something bigger than 1. So we've got r, we've still got an x value, and we've still got a y value. Okay, but if I were to make a circle on here, okay, I could still do that. It's just not going to have a radius of 1, so it's not a unit circle. So if I want to find the trigonometric values of this, so we'll call this theta. If I want to know the sine of theta, I need to take the y value and divide it by the radius. Well, in order to find the radius, we're going to have to use the Pythagorean theorem, because what I've got is, I've got a right triangle here. Okay, this side is x, this side is y. Okay, so this is the triangle that I've got inside there. So if I look, I'm going over 4, and I'm going up 3. So if I want to find r, I'm going to say that 3 squared plus 4 squared equals the radius squared. So 9 plus 16 equals the radius squared. This is 25. So that means that r has to be 5. So now if I want to know the sine of this angle, it's going to be, okay, because this is my angle, I can kind of go back to using SOHCAHTOA. Okay, so the sine of this angle is going to be opposite over hypotenuse, opposite, which is 3. So the sine of theta in this case is going to be 3 over the hypotenuse, which is 5, which you could also think of as y over r. Okay, the cosine of this angle is going to be adjacent over hypotenuse, which is 4 over 5. Tangent was opposite over adjacent. Okay, and then cosecant will be the reciprocal of what I had for the sine. The secant is going to be the reciprocal of what I had for cosine. And the cotangent is the reciprocal of what I had for tangent. So those would be their 6 trigonometric values of this angle. Reference angles are something else we can talk about. This just kind of helps you. I mean, if you memorize the unit circle, reference angles are going to seem kind of pointless. But it can help you in a pinch. Basically, they're angles that would be in our first quadrant. So we want to use our first quadrant angles. So all the angles are in a unit circle that are in this area. We want to use those to find values of angles that are in all the other quadrants. So, for example, this one. The reference angle I would have would be this. It would be this reference angle. It's always the angle that you make with the x-axis. So, in this case, I'm going 19 pi over 6, okay, which is this red motion. which is in the same position as 7 pi over 6, but my reference angle is pi over 6, because I'm pi over 6 away from the x-axis. And I can use this to find the value of different trig functions of the red angle. So here's kind of the way it works. What you want to do is think of the values you get from pi over 6. Okay, so sine of pi over 6. Okay, since that's closest, so I'm going up the least, I get 1/2. Cosine of pi over 6. Okay, so I'm using this as my reference angle. So I'm not going up very much, so I get 1/2. I'm going over as far as I can. Okay, out of the 3, I'm going over the farthest on this one. So that means this is the square root of 3 over 2. Okay, and then we can deal with tangent. So I'm going to use this reference angle values to find the values here. So I know that pi over 6 has these values. So if I want to know the y value down here, what I'm going to do is I'm going to go from the spot I'm at. Okay, I know that if I'm in the third quadrant, my sine value is going to be negative. So that means the sine of 19 pi over 6 is going to be negative of whatever the sine of pi over 6 is. Okay, the cosine value is going to be the same, only since it's in the third quadrant, it's going to be negative. So I'm going to get the same thing here. Negative square root of 3 over 2. Okay, and that's kind of the way reference angles work. Again, if you know your unit circle well enough, you're not going to have to do this. Let's look at a couple more example problems, things you will be required to do. So find the 6 trigonometric values of theta. And there's a couple ways that they can have you do this. So the first one is they'll give you the value of one of the trig functions. And they'll tell you which quadrant it's in. Because really, cosine of theta, if it's this value, there's 2 places that we could have a negative cosine value. Okay, we could be up here or down here. So they have to tell you which quadrant it's in, otherwise there's 2 possibilities. Because here I could have a negative cosine value, or I could be down here. But they're telling me I'm in quadrant 3, so I'm somewhere over here. And they're telling me that the cosine value, which is the x over the radius, so I know my radius, I'm going to draw this a little bigger. So they tell me the radius is 5, and my x value is 4. So I can set up this right triangle and determine all the other values. Okay, this is 4, this is 5. So if I use Pythagorean theorem to find the missing side, I could say that a squared plus b squared equals the radius squared. So you get 16 plus b squared equals 25. Okay, and I'm going to get b squared equals 9, so b is 3. It's that same 3, 4, 5 triangle that we ran into earlier. And now I've got all of 3 parts of my triangle. So since, I mean, this is theta, okay? But since I'm over here, I can kind of treat this as theta and just make sure that you assign the correct values. So since I'm in the third quadrant, both of these need to be negative, since I have a negative x and a negative y to get to this point. So now, if I want the sine of theta, I'm going to take the y value over the radius. If I want the tangent, okay, I'm going to take opposite over adjacent. So negative over negative is going to give me positive. Okay, and then I can get all the other ones by reciprocating these. So the secant is going to be -5/4. The cosecant is going to be -5/3, and the cotangent is going to be 4/3. Another way they could do it is they could give you an equation. Okay, so they're giving me some line equation, and they're saying that it ends in quadrant 4, so I must have some kind of equation that goes through here. Okay, and it does go through the origin, which is going to have to be a prerequisite. But because I know it goes to the origin because I put in the point 0, 0, I get an equation that is true. 0 equals 0, so I know it's going through the origin. And now I just need to find a point that's somewhere in quadrant 4 that's on the line so that I can use it as points to make my line. So all I need to do is pick an x value that's over here, and that's going to give me a value in this quadrant. So we can pick any x value. Let's pick 2. Okay? So if I put 2 in the place of x here and solve, I'm going to get 8 plus 3y equals 0. Subtract the 8 over, divide by 3. So now I've got a y value. So I've got this triangle that I've made. Okay? So I've got 2. This is down 8/3. Use my Pythagorean theorem to find my r. So 2 squared plus 8/3 squared equals r squared. 4 plus 64/9. Okay, if I'm squaring a fraction, I square the top and the bottom. Equals r squared. If I add these together, 9ths, this would be 36 ninths. Okay, 4 whole things. If I split it into 9 pieces, I get 36 ninths. Plus 64 ninths equals r squared. This is 100 ninths equals r squared, and I can square root these and get 10/3, which is r. And now I can go through and find all my trig values. Because I've got this triangle, 2 -8/3 and 10/3. So the sine using this triangle, okay, is going to be opposite over hypotenuse, -8/3 over 10/3, which is the same as multiplying by the reciprocal. Cross reduce, those go away, this goes to 4 and this turns to 5, and I get -4/5. Okay, if I want the cosine, I'm going to take adjacent over hypotenuse 2, multiply by the reciprocal, cross reduce, I get 3/5. Okay, the tangent, opposite over adjacent, -8/3. Divided by 2 is the same as multiplying by 1/2. Cross reduce, so I get -4/3. And then we can reciprocate these to get our remaining trig values. Okay, so the cosecant would be -5/4, the secant would be 5/3, and the cotangent would be -3/4. Or no, yeah, 3/4. Okay, so that's how you can use, I mean, kind of just right triangle trigonometry is basically what we're doing here. We're using coordinates. The next thing we're going to have to do is start solving right triangles, and we'll get into that. So that's jumping it up a step and figuring out how to find missing angles given sides and things like that. So that'll be the next lesson that comes up here.